Hi, my name is Luke Sodolak. I'm a junior mechanical engineering student at Lamar University. And today I'm going to show y'all a really cool project I did over a key principle in fluid mechanics. Pascal's law states that a pressure change at any point in a confined, incompressible fluid is transmitted throughout the fluid such that the same change occurs everywhere. What this means is that a small force applied to a small area can produce a much larger force when the fluid is applied to a larger area, as shown in the diagram here. So to demonstrate this principle in action, I built a small version of a hydraulic lift. So first I'm going to show you all the process of how I made this device, and then we're going to put it to the test and show it in action. First, I cut some boards to make the base. Then I used clamps, wood glue, and screws to assemble those boards together to form the base. Next, I drilled two holes, one of smaller diameter and one of larger diameter, in the top of the display. Then I got two syringes, one of smaller size and one of larger size, and glued them onto small pieces of wood to act as stands on top of the syringes. Then I inserted the syringes of larger size and smaller size into their respective holes and glued them onto the top of this stand so that they would remain stable. Then I requested a little bit of help from my dad in cutting a brick so that we then have two pieces, one of about 1/3 of the brick and one of about 2/3 of the brick, to use as the weights for our demonstration. That was fun to watch. And now the end product of that is these two pieces of a brick. One much smaller than the other one, as you can see here. So now we're going to get down to business. Here you've got the syringes with the green fluid in the tube and the two pillars on top. I can tell even with my hands, it's much easier for me to press down on the smaller syringe than it is with the larger syringe. That took me a while. This one I can just easily push down. But now we're going to actually test it with the bricks. So I'll even them out first. I'll take a larger brick and I'll place it on the syringe of the larger diameter, and it's going to drop on its own. So now this one is fully extended up, the smaller one. So we take the smaller piece of brick and we place it on top of the smaller syringe, try to get it balanced, and then it lifts the larger brick. I hope you enjoyed that cool demonstration of a fluid mechanics principle in action. I wanted to give a few little pointers before I finish the video for anyone that may try to do this project or something similar in the future. A couple of problems I ran into along the way was that there's a lot of friction in these syringes from how the syringe itself is made and how it works. And to overcome that, I had to use heavier objects on the platforms to be able to have the system run as it's supposed to. I was planning on using like Hot Wheels or smaller things. That didn't work, so I had to find something heavier, and I used the brick, which I think worked really well. In addition to that, when we were making the system and filling the tube with liquid, it was hard to minimize air getting into the tubing. So this is pretty good. There's a very, very small bit of air inside the system. But as you know, the less air, the better, because air is compressible. And so air does not work with this principle. That's why it has to be an incompressible fluid. So if you try this again, try to get as small of an amount as air in the system as possible, and it will work to its best. However, I think this one worked really well. I think everything went really great. Like I said, I hope you enjoyed it, and thank you for watching.